Welcome to the Denver MuleSoft Meetup, hosted by the integration lovers at Big Compass. Today we are joined by MuleSoft Ambassador, Josh Erney, who will be covering the 5 easy steps to effective unit testing in MuleSoft.
All right, so this is me a few years ago. My name is Josh Erney. I'm a MuleSoft Ambassador. I've been developing or architecting MuleSoft solutions for about 5 years. I've kind of embraced more of the developer role in the MuleSoft world for the past 5 years, and I have the architecture role, but I tend to dabble in both. I typically approach software development from a financial and long-term maintainability standpoint. So I'm always thinking about value, either reducing the cost it takes to develop the software, reducing the cost it takes to maintain the software, or increasing the profit that we can get from creating the software in some way. I tend to live by this motto in software that if you want to go fast, then you need to do it right. I think most people are familiar with this triangle where you have these 3 qualities of a project. You can either do the project fast, you can do the project at high quality, you can do the project cheaply. And the idea is that you pick 2 of these things and you're sacrificing the other one. In my experience, this is kind of a fallacy. It just doesn't tend to work in software development. This triangle tends to work if you're doing a project once. So for a piece of software that you're going to write once, a piece of software that you're going to use once and never use again. I'm sure you are all familiar, if you've been developing for more than a few months, that the software that you write is going to be maintained over time. You're going to be adding new features. It's going to be used for a long time by potentially many different clients as well. So this idea that, let's say, okay, I want to develop this project fast but I also want it to be cheap. You have to sacrifice quality in that instance. So you lose all this quality for your software. Then the next time that you need to develop it or add a new feature on, you can't make the same choice. You can't just go fast and cheap anymore, because the lack of quality that you've put into your software on the first iteration no longer enables you to move fast. And now that you can't move fast, you can't move cheaply either. So I caution you with making these trade-offs, and just kind of put this here as a disclaimer that this is typically just to let you guys know how I think about software development. I've got 2 dogs here. This is Eddie and Benny. Eddie's on the left and Benny's on the right. There's a little heart for him. I wrote the tutorial for the Data Weave Playground, if you all are familiar with that. I'm not sure if this is my local. No, this is developer.mulesoft.com. So if you click the tutorial here, I wrote the majority of the content for this. This is all interactive. So if you've ever enjoyed the tutorial on the Data Weave Playground, I had a hand in that. And I wrote half of the Data Weave book once, which is up on the internet as well. So let's get into the actual presentation here. 5 steps to effective unit testing in MuleSoft. So the 5 steps that I like to use are: 1, understand the value of your unit tests; assert your code meets interface contracts; write testable code; remove any noise; and make sure you're writing all your valuable tests first, and then concern yourself with code coverage second. So where did these steps come from? Over the past year or so, I was doing a lot of code reviews. And these are the things that I found. Despite overall increases in code quality, the tests were still lacking. So the conclusion I came to there was that even though these developers were getting better and writing better code over time, that didn't immediately translate into them being able to write good tests. Developers were writing unit tests because they were required to, specifically because, 1, a lot of times managers will just say, hey, you need to have unit tests, and 2, they will have a certain code coverage that they want you to meet, which requires, obviously, that you write unit tests. But these tests were weak. Weak in the sense that you could break the software from working correctly in terms of the requirements, but the tests would still all be passing. So the tests weren't a good indicator of whether or not the software was correct or not, which is why we write tests to begin with. The code was, this is what I was referencing earlier, code was passing automated build and deploy processes in our CI/CD pipeline, but when it got sent to QA, it still had logic bugs on the for the code that the test was actually testing. Code coverage was high, like in the 70 to 80%, but test quality was really bad. And after speaking with developers, I learned that most just, they couldn't write good unit tests because they didn't understand the value of the unit tests. So ultimately, having unit tests just isn't enough. In fact, if you have poorly designed unit tests, it ends up being a net negative. We lose productivity and maintenance costs end up increasing. So it takes us longer to develop software in the future if we want to add features onto existing software. At the end of this talk, I would like you to be able to describe why we write unit tests, identify high-value test cases within your code, understand how to write these high-value tests, how to write testable code and refactor non-testable code into testable code, and understand why we need to be thoughtful when using the test recorder. So number one, understand the value of unit tests, keeping the end goal in mind. So why do we create unit tests and what makes them valuable? Usually this would be a question that I'd ask live and get some good feedback on, but we're just going to carry on here. The value of unit tests. So they may increase the code quality. All of these aspects of valuable unit tests are going to decrease maintenance costs and increase developer velocity, or just make sure that it remains the same instead of decreasing over time. So we may increase the code quality. We may enable developers to confidently refactor. And what I mean by that is developers can go in and change the internals of the application without affecting any of the external functionality. And they can do that while being confident that those changes didn't break anything. Having valuable tests may enable developers to confidently add new features without introducing regressions. So I add a new feature on one endpoint and I can be fairly confident that I didn't break features that were already existing on other endpoints. That might happen if you are like modifying shared code, for example. You might modify it in a way that makes it work for what you're trying to build, but breaks that same functionality for pre-existing code that's using that shared resource. It may reduce the quality of bugs, and it may serve as a form of documentation as well. I often find myself, if I'm confused about how a piece of code is supposed to work, how a flow is supposed to work, for example, what variables does the flow expect to be in place? What kind of payload does it expect to be working with? I will often go to unit tests to answer that question first before I go into the RAML and look at the payload, or maybe even ask the original developer what's going on with the code. So when I read all those things, this is what I see. They're all maybes. Just writing unit tests alone doesn't guarantee that we're going to get any of these benefits. They don't come for free. If you write tests that just run through the code and don't assert anything valuable, if you're in that case I was talking about earlier where the tests all pass, but the actual implementation is broken, you're going to see that you don't get any of these benefits at all. And in fact, it might be the opposite of this. Your developer velocity might be going down. Your maintenance costs might be going up over time. So the tests you write not only verify the application is working like you expect it to, but they're also for future you or any developers who may need to modify code in the future to inform them of those same things. So trivia question number one. What is one of the benefits of writing valuable unit tests? A, it makes your boss happy. B, it may reduce maintenance costs. C, you get better code coverage. Or D, you may eliminate all the bugs from your application. Brian, I'm not really sure how long to wait. Do we just wait till
we just give them a few seconds here. We actually have a variety of answers. So I give them a few more seconds. I see one of my former customers already. Now I know why that person joined, because they answered E, which is not an option. So anyway, so what is the correct answer?
Correct answer is B. It may reduce maintenance costs.
Okay, so the first person I see that answered it B, the person's name, Madhava. Please DM me or Stephanie with your email address, and we will send you the Google link. So congratulations, Madhava. So go ahead and continue on, Josh.
All right, we'll do. So let me go over some of these other potential answers real quick. Writing valuable tests is absolutely going to make your boss happy. C, you're not necessarily going to get better code coverage. In fact, I've seen many instances where I will take an application that has 80% code coverage, blow up the test, like the 1 or 2 tests that they have in the application, and start with 0%, and then add the tests that I think are beneficial. And my code coverage is only like 30 to 40%. So adding valuable tests doesn't necessarily give you better code coverage. And we'll talk more in depth about that later. And D, it may eliminate all bugs from your application. This just isn't possible, unfortunately. Unit testing is good for uncovering a certain class of bugs, but it's not going to uncover all of the bugs. And you can write tests, as many tests as you want. You can write unit tests, integration tests, end-to-end tests, and cover your entire system in these tests, and you're still not probably going to eliminate all the bugs in your application. But it doesn't mean we shouldn't try. Point number 2, we want to assert that code meets interface contracts. What does that mean? So given we have these inputs, X, are calls to dependent APIs correct? For example, and I'll show you guys some example code that demonstrates this as well. But if I have certain query parameters coming in through my API router, and I make some downstream calls to other APIs based on that query parameter, are those calls correct? Am I using the correct data in those downstream calls? And if this is a synchronous API and we expect some kind of response, is the response correct? Is the payload correct? Is the HTTP status code correct? If there are any headers that are, I would say, non-normal, so like something you don't have like content type or accept headers, those are pretty normal. I wouldn't typically make assertions about those. But if you have any custom headers that go back to a client, you'll want to assert that those exist as well. So tests should fail if code does not meet interface expectations. You often see this assertion that payload is not null at the end of a test, and that's almost always a red flag that the person who wrote the test wasn't very clear with how the test adds value to the overall application. Tests of this type, tests that assert code meets interface contracts, should never be viewed as optional. These are always the first test that you should write, in my opinion. And interfaces are not necessarily just like your API contracts, for example. Yes, those are really important interfaces, but if you recall something I said earlier, when I look at a flow, I'm curious about what variables and what type of payload that flow expects before it can start doing work. Those are also interfaces. So any input to a flow is its interface, and their output is part of their interface as well. In other words, the Mule message is the defined interface for flows and subflows, but you need to be more specific about the assertions, not just, is it a Mule message? Because yes, it clearly is. But what variables need to be in that Mule message? Are they the correct type? Are they the expected values? So on and so forth. Okay, so I'm going to show you all an example. First, I'm going to talk a little bit about what this code does. Can everybody see this okay? Because I know it can be a little small.
Good.
It looks fine on my screen.
Okay, awesome. So I fixed that problem from last time. This is my second time doing this presentation, so the goal here is the problems I had last time, I will not have this time. So that's one of two that's been solved.
So you'll introduce new problems, or you debugged everything?
That's what you hope for. I'm all about just reducing the number of errors as opposed to continuous improvement. Okay, so I didn't expect that to be there. Give me 1 second here. Oh, right, okay. Wonderful. Okay, so this is the only flow in our application right now. It listens in on /API/activities. Let me see if this will load for me. Yep, the listener is configured, the base path is API. So if I call get activities, it'll hit this particular flow. We just log that we're getting activities here. We do a scatter gather, and we make a call out to this API. It's called boardapi.com. And what boardapi.com does is you pass it some information with some query parameters. And oh, I have the example over here. Get that. So check out this. So boardapi.com/API/activity, type is education. Go ahead and hit enter. And this is what we get back. We get an activity, the type of the activity, how many participants, so on and so forth. And if I call this endpoint again, I get different information. This time it's learn how to fold a paper crane. That sounds fun. Learn GraphQL. Also fun, depending on your idea of fun. And you can also change the type. So you could do social. I think relaxation or relaxing is another option. We're only interested in social and education activities. We're going to use this API to help us decide what to do on weekends. So we're going to fold a paper crane and play football with our friends. An odd combination. Once we get that information back, we're just going to format it into XML and get this particular data here. Man, this is giving me all kinds of problems with the loading. There we go. I'm going to go ahead and run this and show you guys an example of it running. And I'm also going to show you the test that we'll create to test that this flow is working correctly. Let me check something real quick. Task manager, is it? It's, somebody help me out. What's the Mac OS task manager called? Activity monitor. I'm going to kill this real quick. Brian, I think you jinxed it when you said new problems. Haven't seen that one before. Okay, I thought maybe I'd have a rogue Java process. That does not seem to be the case. Worst comes to worst, I can walk through this, without actually running code. But I would really like it to run for you all. So let me get this started. Give it one more go.
I'm not getting confidence in version 7.11.
Well, welcome to MuleSoft meetups, where I make MuleSoft look bad. I thought you had to. I thought you actually had to download the new Anypoint Studio versions. I didn't think it was gonna update. I think I had 7.9 before this. I didn't think it was gonna automatically update to 7.11 when I.
Yeah, I'm surprised. Usually, you have to authorize it to do that. You have to say yes. I really do want to do this.
Yeah. All right, we'll give that a few seconds here. Let me check my presentation. Maybe there's something interesting I can talk about while this is happening. Now my presentation's frozen. Okay. No, probably not. All right, let's give this one more shot here. I'm gonna do this. Maybe this is the problem. All right, we'll give that a go. This is the test case I put together for this particular application. When I reach out to that API, I'm mocking those two endpoints. And and what I like to do with mock data, if we look in here, if it wants to load for me, I put all my mock data in something called test fixtures. So in source test resources, I do test fixtures. Then I name whatever MUnit suite that I'm currently in. And under that, I have a folder for each one of my tests. So this particular test, I have 3 files here. 2 of them are what I would like examples of what I could expect to get from the board API. So this should look very similar to you guys. And then response payload XML, which is what I'm expecting to get back given these 2 inputs here. I think I opened that. Yep. So that's what I'd expect to get back. And you can see these things line up. So this one is learn calligraphy education. This one has learn calligraphy education, so on and so forth. I find that organizing your test data this way is really helpful, especially if you use good informative names when naming your files. All right, let's see if this thing ran. Okay, so we're not doing that today. Okay, no problem. I think my tests aren't going to run either, unfortunately. So let's look at what we're asserting here. This is, a lot of times I see here payload is not null, which is probably like the weakest assertion you could make. By saying payload is not null, you really open up an almost infinite number of possibilities for what the payload could possibly be. And there's no way your client is, your API client is okay with receiving any kind of payload it could possibly get. So it's always important to assert that the data is exactly how you think it should be. You don't want to use some very general thing like the data is an array, the data is an object, the data is not null. Assert the data is exactly what you think it should be based off of the inputs. So that's what we're doing here. Let's see. If I'd run that, you'd see that they'd pass. And now we need part 3, right? Testable code. So what makes code testable? Testable is code isn't necessarily testable or not testable. Testability is a spectrum. But you can usually tell if you're really struggling to write a test, or you find that a test is actually impossible to write, your code probably isn't testable. And there are some changes you can make that are usually relatively easy changes to make that can make your code go from untestable to testable. Some other indicators that your code isn't really testable is if you need to mock a large number of components for your test. That can be indicative of a few things. The main thing being that you probably need to refactor a bit and break your code down into smaller flows and subflows if you need to mock that much. Code that is thoughtfully organized into flows and subflows is typically more testable than code that is not. I generally suggest that people bias towards code organization that reflects how you would communicate about the code to somebody else. So this flow gets data from system X, collects associated data from system Y, then groups the data and sends it to a queue. That might be three or four different flows or subflows, and maybe even a fifth flow that orchestrates all of those flows to work together in the correct way. This one's really important, which is why it's bold. Values that need to be tested must be visible for testing. Let's go back to the code real quick, and I'm going to show you what I'm talking about here. So let's say I go into one of these HTTP requesters, and I change the query parameter. Now, the requirements for this project are that I get an educational activity and a social activity, combine them and return them as XML. Now, if I take this education activity and I change it to be relaxation activity instead, I've broken my code, right? I'm no longer within the requirements. I'm getting a relaxation activity instead of a educational activity. But is my test going to break? If I could run my test, which I cannot, I would tell you that it doesn't break. And let me run you through the flow real quick. So the test starts, we go into the execution section, and we go to this flow reference get activities flow. That brings us here. We go ahead and do the log. We do the scatter gather. When we get here, all we're doing is we don't even enter that processor really. It's like, okay, that's the get education activity processor, our component. We're going to mock that, and instead we're just going to return this value. So even though the implementation is off, and I'm over here in the actual source code saying, yeah, I get a relaxation activity, the MUnit test doesn't really care about that because that information is contained in the processor that it's mocking. So it's still going to return the education activity, and my payload is going to be asserted to be correct. So this is still going to pass, even though my application code is essentially broken. So how do we fix that? And what's the main problem here? Well, the main problem is that the value that we really need to test here, which is this object type, the query param type, we need to test and assert that that is education and not some other value. So one way we can do this is extract our query parameters or any other kind of data that we might send into a mocked processor, extract those things as variables. Because what we can do, if we do that, is eventually in our test code, what we'll do is use a spy on those particular processors and assert that those values are correct before we enter those processors. Now let me show you the code that actually does that. I'm not actually going to write this code live. Because I don't think anybody's here to watch me write code. So what I'm going to do is kind of just fast forward to the code that shows what I'm trying to show you guys here. Okay. So I extracted these variables, query params, and I have type education here, type social here, and in my HTTP requester, which I'm currently mocking, I'm just using that variable for query params. Now this enables me to actually have visibility into what query params are supposed to be before they go into the request. So if I wanted to modify my code here, my test to actually account for these things, I would set up 2 SPI processors and assert that these values are correct before calling the actual HTTP request. And let me show you what that's going to look like here as well. All right. So here I've added 2 SPIs. So if you're not familiar with what SPIs are, you basically point them at a specific processor in your source code, and they can make assertions about the Mule message before that processor is called and also after that processor is called. When you mock a processor, if you're spying on a processor that you're also mocking, you're never really going to assert anything afterwards because you've hard-coded it into your test what the after values should be. But you will often find it useful to look at what happens before the call. So in this case, we're using a SPI to assert that the query params are expected. So before I get educational activity, what I'm asserting here is that the query params variable is type education. So now we've essentially, I do the same thing here for social activity. So now by extracting that variable from the mocked processor, I've taken my code from something that's not testable that a developer could easily break with no resulting unit test failing to code that is testable. And if a developer were to come in here and change this to be social, so I'm getting 2 social activities now, my test would actually break and let the developer know, hey, that's basically a violation of the test we have for this application. You might want to think twice before making that change. Okay. Back to the presentation. If I can find it. There we go. So testable code is also deterministic. And what I mean by that is deterministic code is where you give it, if you give deterministic code the same inputs, you're always going to get the same outputs. Math is like a deterministic thing for the most part. 1 + 1 is always equal to 2. There's nothing you can really do to change that. 2 + 1 is 3, and that's not going to change over time either. There are functions in DataWeave that you can use that are non-deterministic. These are functions like now and random. If you call now right now, and you call now 5 minutes in the future, you're going to get 2 values back despite the fact that you pass this function the same thing every time, which is nothing. You have the same case with random. These functions are non-deterministic, so we need to be careful about how we use them in our code because we can easily put them in places that make our code untestable. And let me show you some examples of that real quick. Okay. I'm surprised this doesn't refresh when I do that. It usually does. So here I've added this, I call this flow non-deterministic flow, so you'll know exactly what it is. I obviously can't run this code, so I'm not going to be able to show you the API call for it or anything. But what it does is it just sets a payload, and it has a message, and it says the current UTC date time is below. And then we just take now, we assign it the UTC time zone, and we return that back to the user. So if I call this now, I'm going to get a certain value. If I call this in 5 minutes, I'm going to get a different value. Not great for testing, unfortunately. So let's say I have this test here. I call the non-deterministic flow, and I make some assertions about the payload that we're getting back. Once again, I have my test data in these files. So we have test fixtures, MUnit presentation test suite, and my non-deterministic flow test here. Here's my expected response payload. This is a time in the past. If I run this test now, it's going to fail because there's just no way that it's ever going to be this value ever again. Because now is always returning whatever the present time is. And depending on when you run the test, you're going to get different values. So in order to fix this, this is the case for if you use now, if you use random, if you use any non-deterministic data weave function. You want to pull that function out of the code and set the result to a variable. So instead of having now and there, what I'm going to do is I'm going to set a variable called now. And in my set payload, I'm just going to say vars.now. What this enables me to do is use mocks to make this code essentially deterministic. I can mock the set variable component and make sure it is assigned the same value every time I run the test. I'm also not going to write that code. I'm just going to check out the commit that has this code. Okay. I just did it by itself this time. How nice. So here I have this mock. I'm pointing at that set variable processor, and I'm just assigning it this hard-coded variable every time. Now this value lines up with the value I have in my response payload.json file. This test is going to pass every time, assuming somebody doesn't come in and intentionally break it or accidentally break it. But that's how you take non-deterministic code, usually coming from DataWeave, and turn it into a way that you can make the test deterministic and make it work every single time. Does anybody have any questions there? I know that can be kind of confusing. Can you use a spy?
Yeah, okay, you got it. Go ahead.
Yeah. Oh, is that Nahom? Can you use a spy scope to assert a payload after a transform message? Yeah, you can. Like maybe if the transform message component was in the middle of a flow and you wanted to assert something about it afterwards, you could do that. I would say, to me, that's kind of a code smell. If you need to assert the value of that payload in the middle of a function, in the middle of a flow, I would probably refactor the code so that it's the output of a function of a flow instead. So instead of having that transformer in the middle of a flow, I might pull it out into its own flow with some other related processors and just assert that the result of that flow is correct instead. I typically only use spies in order to make assertions about passing variables to things that are passing data to things that I won't have access to during a test. So for example, with the HTTP requester here, there's no way I can look inside of this in the middle of a test and make sure that whatever I've done here is correct. I can't make any assertions about vars query params once I'm in this, but I can make assertions about it beforehand. So that's usually how I use SPY, before and after. But yeah, you can. I would just say to be cautious, because it's more likely that doing a little bit of refactoring is going to be more beneficial than using the SPY to test before and after the transform message component. Okay, let's keep going here. All right, back to the presentation. I think I might have a, second trivia question here. So what is a good indicator of testable software or testable code? A, it has good naming conventions. B, the software already has a lot of tests. C, software tests provide great code coverage. Or D, non-deterministic values are extracted into mockable variables.
We have some answers coming in, and looks like the majority answers I see are letter D. Is that correct?
D is correct.
All right. According to my chat list, Saddam, and I'm probably going to mess your last name up, Shaikh, you are the winner. So please DM us your email address, and we'll be able to send you the Google link out.
A few things about these other answers. Good naming conventions can be an indicator of good software, of testable software. Typically, someone that has good naming conventions is probably a pretty experienced developer as well, so they're more likely to write testable software. But there's not necessarily any kind of direct correlation there. The software already has a lot of tests. This was just kind of a joke. The software tests provide great code coverage. Again, like, code coverage can really be an empty metric if you don't know that your tests are solid. So be careful there. Let's see. Already did that. 4, eliminate the noise. Noise in software is like any code or a test that cannot be linked back to a requirement or an interface contract. So for example, if you have like an empty variable, like if you assign a value to a variable and then you never use that variable, that's noise. A developer is going to look at that, and all you're going to do, if you wrote the code, all you're going to do is confuse that developer. They're going to look at that variable and wonder, am I going to break the code if I delete this? Why is it here? So on and so forth. And then you kind of just create this, doubt in the person who's modifying the code, and that's going to end up slowing them down, which we don't want. Noise could also be a test that doesn't assert anything useful. You remember me talking about asserting that the payload is not equal to null. That's not asserting anything useful. That's just noise, unfortunately. If the test is offering no real value, it's just noise, unfortunately. Noise ends up increasing our maintenance costs instead of decreasing them because of this confusion that I alluded to in the first point. And the MUnit test recorder can create a lot of noise, so we need to be really thoughtful when using that. I'm going to elaborate more on that later in the presentation. So the 5th and final point, valuable tests first, code coverage second. Like I've alluded to earlier in this presentation, code coverage can be a misleading metric for software quality. I have seen code coverage in the 80%, and by looking at the test, they assert absolutely nothing. Everything is mocked. They just assert that the payload is not null at the end, and it's literally just running through all the things, all of the flows, while essentially doing nothing. So we want to avoid that. You want to write your high value test first. check if the code coverage criteria is met, and then add more tests if necessary. So I always start with these interface tests like I was talking about. If I need more code coverage, I might branch into testing other parts of my application that aren't as valuable to test because they tend to be a lot simpler, but only if my original tests are not meeting code coverage requirements. Code reviews should be exposing weak tests. I hope you guys are all doing code reviews where you have a more experienced developer or just one of your peers who is looking at your code, and those developers who are looking at your code should be looking for weak tests. They should be looking for instances where you have a ton of mocks in a test, or instances where you're asserting the payload is not equal to null instead of asserting that it's an expected value given the inputs. It helps mitigate developers aiming for code coverage instead of writing high-value tests, while also teaching those developers how to write high-value tests as well. So some other tips. I added these tips in at the end after I already named my presentation, and I never went back and renamed it. So these are the other tips. 5 tips, effective tips for unit testing is a cooler sounding name than like 11.
So these are bonus. These are bonus tips, is what you're saying.
Yeah,
5 plus a bonus.
These are the bonus ones. Unit tests should not be dependent on the use of the network or file system. You probably already know this one for the most part, but this is why we mock HTTP requesters. This is why we mock things like sending messages to queues and things like that. Once we invoke the outside world into our unit tests, we're kind of robbing ourselves of one of the best parts of unit tests, and that is being able to run them in isolation and run them quickly without the need for standing up external systems. More complex code should probably have more robust tests. So if you have a very complicated transformer, if you have just like a series of like routers and things like that, you're probably going to cover those flows in more tests than you would think. It's not uncommon to for each flow to have like at least 2 tests, and often I find that my tests, in terms of lines of code, my tests are twice as long as the source code that they're actually testing. So tests should function as a form of documentation. They document the expected inputs into flows. So in your execution section, before you end up calling the flow reference, a lot of times you'll set variables here, you'll set the payload, maybe you'll set some attributes, or you'll use the set event processor to, give me a second, that's not gonna go away, great. The event process, you can use the set event processor to set like attributes on the flow or something like that. That's a good cue to the person reading the code that, okay, when I call this flow reference, it's expecting these variables that you've assigned here. In order for tests to function as a good form of documentation, your tests themselves have to have good doc names. So whenever you use a mock or any of these things, you'll notice that I use a custom doc name for all of these that describe exactly what's going on. This is the flow I'm calling. This is what I'm mocking. This is what I'm spying. This is what I'm asserting. I didn't do this in this presentation, but one of the things that I've found that's incredibly valuable is if you fill out the test scenario description. You can use really simple language, like, for example, in this one, I might say, given a call to the get activities flow, then the payload should be what's expected. Or given a call to non-deterministic flow, the payload is expected. For this one, I might also put the query params to dependent APIs are correct and the payload is expected. But if you look into behavior-driven design and look at some of the language that they use to define their tests, they use this given, when, then verbiage. You can use that same verbiage in your scenario descriptions, and it usually goes a long way without too much effort. You should be testing all paths. Generally, flows with the choice router require 1 test per possible path, and this also includes exceptions. So if you have exceptions in your flow, that's considered a path, and all of your choice routers, every branch of those is a path as well. You should have a test testing each one of those branches. Oh man, my scroll wheel. Testing data weave code. Oftentimes it's just not necessary. Your interface test should be exposing bugs in your transformation logic. If you can write your code in your tests in a way that data weave is an implementation detail and could be swapped out for Java or any other thing, you're in a really good position. So Nahom, like when you asked that question earlier, would I put a spy? Could I use a spy on a data weave processor to make assertions before and after it? I kind of thought of this particular point where I don't even typically test data weave directly anymore. You never want to mock on doc ID alone. You always want to at least include the doc name. Nothing is more frustrating than trying to figure out a test and the developer's not provided the doc name and that all they provided is doc ID. So like if this had no other information, it just says HTTP request and I get this GUID here, it's just really unhelpful. It's okay to mock on doc ID, but you should also be mocking on something that's a little more human readable and descriptive, and typically doc name is adequate for that. Obviously with doc name, you have to be a little careful because that can change over time, but once you change it, your tests are probably gonna break, so you'll know to fix it anyway, so that's always nice. And the last point here is you never wanna trust a test if you haven't seen it fail. If you haven't seen a test fail, you have no idea if it works. So break your tests on purpose by breaking your code. It's often, I've found it's good practice to break critical parts of my code. For example, when I was talking earlier about, oh, if I change this query param, then the test isn't gonna break. That's a critical part of the code. If I break that query param and change it to something else, my test should break. And if it doesn't, then I know, oh, I need to create a test for that. Or, oh, the test I had that I thought was covering that is actually not covering it. So always try to break them before you lean too heavily on them, thinking that they are adequate. All right, third and final trivia question. When writing unit tests, why should you focus on writing valuable tests first and code coverage second? A, without valuable tests, code coverage is meaningless. B, code coverage isn't really that important. C, valuable tests are difficult to write, so we should approach them with a fresh mind. Or D, an authority figure said so in an online presentation.
So the answers I'm seeing so far, they are all the letter A. Except
That is
for one.
correct.
The letter A is correct. Tony DeFusco, you were very fast this time, so you are the winner of this one. So congratulations. Please DM us your email. Before you move on, Josh, there was a question about: is there any other way to confirm how good the MUnit test cases really are instead of just the code coverage percent?
It's a really good question, and unfortunately, the answer is, well, the answer is yes, but there's no easy way. Unfortunately, you really need an experienced developer to look at them in order to determine if they're actually valuable. You can use some of the things I told you as well. You can break critical areas of functionality in your code and make sure that your unit tests indeed fail if you do that. But there's no tool that we can inject into our build process or anything like that to really assert that tests are good, unfortunately. It would be nice, but we can't, unfortunately.
So basically the answer is yes, but no real automated way to do it. It just requires good review process.
Yeah, good review process, critical thinking, and a knowledge of the requirements.
Out of curiosity, before you move on, and if you're answering this question, when you are somehow scoping your effort, whether you use points in Agile or just you take a guess, how much additional time should a developer add for unit tests, for creating their unit tests? That assumes some familiarity with the tool, of course.
Yeah. I will think about how long it would take me to just write the code in an optimistic scenario. So there's nothing I need to look up in order to write the code. I have a good idea of how it's going to work. I'm not dependent on anybody else to make it happen. And then I typically multiply that value by 3.
Okay, so
so if I think the code is going to take me eight hours to write one day, I would put forth that it would take me 3 days to complete the task with everything included, MUnit tests and everything.
Cool. Thanks.
Yeah, definitely better to what is the phrase? You want to under promise and over deliver when making estimations, for sure.
That is the correct phrase.
Yep. My thoughts on the MUnit test record. Some things it's really good at, and some things that are kind of unfortunate about it, because it seems like a really well thought out tool, and I feel like a lot of effort went into making it. It's really good at quickly creating test cases. And it's probably going to give you great code coverage if you end up recording every flow. But unfortunately, it's a lot easier to create noise. So for example, some of the things I see with the MUnit test recorder is it records all the input that you give it. So let's say you have the Mule messages representing an HTTP request. It's going to mock all of the attributes. It's going to mock all of the headers, so on and so forth. Not all of these headers are going to be critical to your flow running correctly. And if they're not critical to your flow running correctly, then you really shouldn't be having them in your test at all. Poor file naming for things like mock payloads. What is going on? Can you guys give me a second here?
Rule number 1 about doing presentations: kill all ways of chatting.
Seriously. We'll be over here now. So it's easier to create noise. One of the things I also see sometimes is mocking of payloads that have hundreds of records in them. So you have an array that just has a bunch of records in it because that's what came from one of your data sources. When really you only might need 1 or 2 records to effectively test your code. So you want to avoid situations like that. The MUnit test recorder, it does make its best attempt at naming things like mock payloads, but it doesn't know the context of your application. It doesn't know like the domain and the vocabulary that you use to communicate with the developers about what you're doing. The only people that know that are you. Computers aren't really going to know that. So it can't name things like mock payloads effectively, so that's on you. So if you ever use the test recorder, make sure you go in there and rename some of those files to something that is more in line with the vocabulary that you use to communicate with your team. You can't mock and spy the same component. That ends up being really unfortunate because, as you saw here, mocking and spying the same component is a really common pattern for making assertions about HTTP requests within Mule. So that's kind of a shortcoming that is a bit unfortunate. Mock data is always in application data weave format. That's a big one because, for example, let's say I have a test and part of that test is sending or I have a flow and part of that flow is sending a payload as a post to another API as XML. It would be really nice to copy that XML payload and put it into Postman and be able to test things really easily that way, just to experiment around with that API and see how it works. If the mock data is an application data weave, I can't just copy and paste that file into Postman and start going with testing. I have to put it in the data weave playground. I have to change the output, do all that nonsense. It just creates one more step between you, a developer and them wanting to do something that should be easy. The file generation in the test recorder also tends to clutter source test resources, which is unfortunate. you're not going to have something well organized like we have here with MUnit presentation test suite and folders underneath for each one of the different tests. And then within those folders, any kind of files that we need to run the test. You're not going to get anything like that. So I'm not against using the test reporter. I would just say that keep these things in mind if you decide to use it, because it can do more harm than good if you just let it do everything that it wants to do by default. There is going to be more effort required on your part in terms of making sure that the tests are asserting something useful, and so on and so forth. When it's all said and done, I ultimately find that it takes me more time to work with the test recorder and manipulate all of the files and data that it spits out to be helpful than it would for me to just do it right off the bat in my own way. So I typically do not use it. Unfortunately, guys, no MUnit test recorder example. But that is the end of the presentation.